And we'll go from current slide. All right. Before we get started, any questions on anything so far? I won't go over all these again, but you know about applying for graduation. If not, ask me any questions you may have. If you're at all interested in becoming a note taker, they're looking for note takers. They will pay you to do it. And the Space Center is also looking to hire peer tutors in the area of math, English, biology, computer science, and Spanish. So if any of those strike your fancy, please consider giving them a shot. Okay. No questions on what we've done so far in math, okay? The odds are we're going to finish Module 11 today, which means we will be ready for the test then, once Pablo's here, on Wednesday, okay? So most of you, I think, have gotten in your quizzes. This is a great class of getting them in. I got one more in this morning. Still missing 1, 2, 3, 4, 5, 6, 7, 8, 9. So still missing a few. So please get those in because you really need to have your quiz in before you can take your test. Thank you. All right. Okay. All right. Now, this is where my mark was. We left off last time. Any questions before we get going on this? Okay, this is on Module 11, page 25. It's in Section 11.5, Objective 11.5A. Here's a quadratic equation. Or is that a quadratic equation? What makes it a quadratic equation? Okay. The maximum exponent is 2. That makes it a quadratic. Okay? Now, how would you approach that? You tell me. Say again? Yeah, subtract the 6. In other words, this is not in standard form. What does standard form look like? Everything on the left, 0 on the right. Okay? So yes, our first step is to get my pen color changed. If I can get it to come up. There it comes. Okay. So we'll subtract the 6 from both sides. What does that become now? Help me, help me. 2x squared plus x minus 6 equals 0. Perfect. Now what? Say again? What's the F word? Factor. Okay. Okay. Now, trial and error, AC method, how? What's your pleasure? Huh? Second? Oh, we did it? Did we already do this problem?
Yes.
Why do I have it marked then? Did we finish it? Okay, well then let's move on. I don't know why it's marked then. Okay, there is a check your understanding, bottom of the page, page 25. Does anyone need to see another one like that, or are you okay with how to proceed? Okay, I don't know why that was marked then. Okay. Let me just clear everything I wrote. And for those who may have missed last time, here's the procedure. Write it again. Okay, good. Subtract 6 from both sides. That's what we got. Now, they didn't do AC. Well, they didn't say how they got it. They just factored it. And all indications were they probably did trial and error, which was pretty easy to do on this one too, because there's only one possible factorization here. There were a couple there, but that's easy to find. Okay? Then they said each equation equal to 0, the zero product principle, or principle of zero products, and then solved each one of those linear equations for the for x, and that gave them x equal 3/2 or -2. Okay? Everybody got that? Any questions on it? If you do, ask. I mean, not all of you were here last time. Any questions? How they got from here to there to there, whatever. All done? Any questions? Okay. Now, this is the first time I can recall they do this extensive of a checking. So they checked the first one, putting the 3/2 in here, and carried it through. I think we did that too. And maybe that's where we left off and we hadn't finished checking. See, that checked 6 equals 6 over here, and then the -2 is much easier to plug in the fractional forms. And when you plug that in, you also get 6 equals 6. Which is good to know. Both those answers work. By the way, if I haven't said this before, let me say it again. Okay? When you have a quadratic equation, the most number of solutions you can get is 2. You cannot exceed the maximum exponent. So if you had a cubic equation, the most solutions you could get was a 3. Okay, and so on. With a quadratic, the most you can get 2. You won't always get 2. You may only get 1, or you may get none. Okay, but the most you can get is 2. So once you found 2 solutions, stop. Don't even try looking any further. There aren't any. Okay, and we found both of them here. Any questions? All right. Oh, and there's the 2 solutions. Wow. Write the solutions. We did earlier. Okay, on the 11th slide. So here is the top of page 26. The sort of the summary of how you go about solving equations by factoring. The example on the previous page illustrates the steps involved in solving an equation by factoring. First, write that equation in standard form if it's not in standard form. So that's the first thing you do. Look at the equation. Is it in standard form? If it's not, get it in standard form, and that's the subtracting 6 from both sides on the left. Then, if you can, factor the polynomial. Not all polynomials are factorable. Y'all remember that from the your last module. You know, there were a few that were not factorable. Okay, so but if you can, factor the polynomial. Once you factored it, set each of those factors equal to 0. Because see, in standard form, the whole polynomial is equal to 0. So if you factored it, then set each factor equal to 0 by the principle of zero products or zero product principle. Then solve each equation for the variables. They're linear equations now. Maximum exponent 1. Solve for x. Solve for the variable. And then, as we just saw, check the solutions. Okay? Any question on the procedure? Exactly what we did. This is a little more formal. Okay? Everybody got it? Okay. Let's see if they don't do the next focus. So let's us do the next focus. Oh, I'm sorry. Yeah. Oh, man. It looks like they're doing you a big favor until you look carefully. Here we have x minus 3 times x minus 10. And that's equal to negative 10. Okay? How would you approach a problem like that? Say again? One more time.
You're going in reverse. Put it on. Back it up.
Okay. Wait just a minute. Let me get her coming in. Kayla? Okay. Stinson, right? Okay. That's so many with similar names. All right. Let me get a little closer this time. One more time.
Reverse.
Reverse. Okay, I think I know exactly what you're talking about. What do you mean by reverse? What's the problem here? On one hand, it looks like they factored it for you. Yay! Okay. But on the other hand, that's not a zero. Okay. So now you've got to multiply them, FOIL it, whatever you want to call it, and get it into something that looks more like standard form here. Then you can subtract the minus 10 or add the 10 to both sides to get it back in standard form. So the problem here, not in standard form, even though it looked like it was factored. So go for it. What do you do first? X times x is x squared. Then is negative 10x and negative 3x. And is positive 30. And that's all equal to negative 10. Okay? Well, better combine like terms first. So let's see. X squared. What's next? Help me, help me. Negative 13x plus 30 equal negative 10. Now what? Add 10 to both sides. And that gives us x squared minus 13x plus 40 equals 0. Now what? Unfoil it. Okay, we just foiled it to get here. Now we unfoil it. Now, how do you want to do this one? Help me out. English? Johnson. Okay. Highly, right? Okay. All right, slowly filling up here. All right, how do you want to do it? Trial and error? AC. Say again? Pretty exciting, huh? Okay. Let's try trial and error. I can't get an answer, so let's try it. Okay? Only possible factorization for x squared. X times x. Perfect. Okay? Now, where do we look next? Sign of the last term, what is it? Plus sign. What does that tell you about these two signs? They got to be the same, but what do they have to be? Both negative, because that middle sign is negative. Okay, we want two numbers that multiply to be 40 and add to be 13. 8 and 5. Perfect. And what do we do now? Yes, separate them. That would be x minus 8 equals 0, or x minus 5 equals 0. What's the first one yield? Add 8 to both sides, and that gives us x equal 8. And over here, add 5 to both sides, and that gives us x equal 5. All right. Never a bad idea to go back and check. Okay? So let's start with x equal 8. 8 minus 3, 5, times 8 minus 10 is what? Negative 2. 5 times negative 2, negative 10. That one checks. Okay, this one, 5 minus 3, say again, 2, and this one would be 5 minus 10, negative 5, 2 times negative 5 is also negative 10. So both of those work. Those are our solutions. Good deal. Any questions on that? All right. There's another check your understanding. This is on a fairly similar type problem, and you can see the solution on page S-6. Sorry about that. So please do those check your understandings as soon as you can after you get out of class, just to make sure you reinforce what we just did. All right. There are some objective 11.5A practice problems. There's 5 of them there. Please do those as homework. Okay? The sooner the better. And those solutions are on page S-11. Now, that finishes the slideshow for 11.5A. I'll go through all these other slides. And let's get out of this. And go to 11.5B. All right. Slideshow set up and current slide. Okay, again, we see Module 11. Whoa, I skipped right over here. Module 11, Factoring Polynomials. Section 11.5, Solving Equations. We've been there before. Now we do Objective 11.5B, Solve Application Problems. All right, put the, where the rubber meets the road here. Okay, let's see. Yep, this is the same one. A stone is thrown into a well with an initial velocity of 8 feet per second. So you're throwing the stone into a well. The well is 440 feet deep. How many seconds later will the stone hit the bottom of the well? So we're looking for time here. Always look for what you're asking for. That's a good thing to be your variable. How many seconds? That will be probably t. But you can use any variable you want to. I like t for time. Now it says, here's the equation. You see, they use t for time too. Where d is equal to v, I usually use v0 for initial velocity, t plus 16 t squared. Okay? Now, where d is the distance in feet, so there's the distance in feet. V is the initial velocity. There's your initial velocity. T is what we're looking for, how many seconds. Where did that 16 come from? Anyone have a clue? Where the 16 came from? You don't need to know that. I'm just letting you know. That's your acceleration. Okay? The acceleration in the U.S. customary system, feet, seconds, that kind of thing, is 32 feet per second squared. The acceleration due to gravity, 32 feet per second squared, now that Gary's here. We all know it. Okay? So we're only missing a few people now. Okay. Now, so we have everything that we need. T is the variable, the 16. Oh, I said 32. So that's the 16. 1/2 of 16. Any of you had physics yet? High school or wherever? Remember the formula? D is equal to, if you had an initial displacement, d0 plus v0t plus 1/2 at squared. And the acceleration due to gravity is 32. Half of 32 is 16. That's one of your standard physics, what they call, what is it? Some sort of equations. Kinematic equations, okay, that you would use in physics. All right, so since we know everything but time, I think it's probably best, in a lot of cases you get an option between plugging and chugging or chugging and plugging. In other words, plug in the numbers first and then solve, or try to solve and then plug in the numbers. I think this, because it's a quadratic, you're going to need all those numbers first. So let's plug in the numbers first. What's your D? Let me get my pen set up while you're figuring that out. What's your D? Distance in feet, which is 440. So 440 is equal to, what's your V? Say again? A little louder. It's velocity. And what is it? 8. Okay, 8 feet per second squared times t. What next? Plus 16t squared. All right. Now, there's several directions you can go here. What would you do next? You have several options in front of you. What would you do next? Some of it depends on how you like it to look. Some of it depends on making it as easy as possible. What would you do? Okay, a little out.
Subtract 440.
Okay, now here, subtract 440 from both sides. Sounds like a wiener to me, okay? 440 from both sides. I don't even know where to put it, but I'll put it here, okay? What does that give you? Now, again, you have some options and choices. How would you write this? Okay, he's going to get it in standard form with everything on the left, 0 on the right, okay? So he's basically flipping sides on it here. So 16t squared, go on, plus 8t minus 440 equals 0. Okay, you see what he did? He moved everything to the other side, which is fine. I thought someone might do that first. Next. Now you're down to very few options, I think. What would you do next? Anybody? What's always our first step? Next step, whatever. Say again? Okay, factor. And what's our first step to factor? Say again? Yes, let's factor out greatest common factor. And Gibron is suggesting it's an 8. Do y'all concur? Let's try it. Factor out an 8 from the first term, and what do you get? 2t squared plus t minus 55. And that's equal to 0. Okay? Next. Next. What you think? A little louder? Unfoil it. That sounds like another good thing to do. Now, I'll keep it. Okay. Let's keep the 8, because that is a factor. Now we're going to try to unfoil the 2t squared. I think I'll do it down here. I thought I wouldn't have room, but let's try it down here, okay? What's the only possible factorization in 2t squared? 2t times t. And then where do we look next? Sign of the last term, and what is it? Negative, and what does that tell you? Say again? Plus and minus, is that what I heard? Okay. The thing is, we don't know if it's in the right place yet, but we'll figure that out. And then we're looking for possible factors of 55. Now, there's not that many, so pick me one of them. Say again? 5 and 11. Okay? Now we're going to check ourselves, and supposedly that's equal to 0. So let's check ourselves here. I'm going to erase this up here because I decided to write it underneath it. Okay? Now, let's foil this and see. 2t times t is 2t squared, so that checks. And then you have a, say again? Minus 22t plus 5t, that would give you minus 17t. Not what you've got there. How is it wrong? the wrong number. Okay? So therefore, let's change numbers. Okay? The only two numbers we really need to play with are these two. Let's just swap the order there. Okay? So let's go back. Erase. We'll erase that, this, these, that, and that. Okay? Now let's erase here, put in the 11 here and the 5 there. Okay? Let's try it again. 2t times t, 2t squared. That works. What you got there? Minus 10t plus 11t. Ding, ding, it works, right? That gives you plus t. Now, if you had done it, gotten the signs wrong, then you would have just been off by the sign. Then just change signs. Before we had the numbers wrong, so change numbers. So we've got the answer now, and then finally a minus 55t. So I'll write that up here. 8 times 2t plus 11 times t minus 5. That's equal to 0. Why did I write that again? I don't know. What do you do with that now? Now you have 3 factors that multiply to be 0. What does that tell you? Anything? Anybody? Okay, at least one of them has to be 0, right? Correct? Okay. For 3 things to multiply to be 0, one of them, at least one of them's got to be 0. Now my question to you, is 8 ever 0? Not in this universe. Okay? So therefore that one's completely out. Okay? How about 2t plus 11? Could that be 0? Well, it could. 2t plus 11 is equal to 0, or t minus 5 is equal to 0. Zero product principle, huh? Anytime you have a bunch of things multiplied to be 0, some factor of those, one of those things has to be 0. We know 8 can't be 0, so one of the others must. So what do we do with the first one? Help me. Subtract 11 from both sides, and that gives you 2t is equal to negative 11, and then divide by 2, and then you get t is equal to negative 11 halves seconds, right? What's that? We're not doing what?
You use the 11 and 5, we're not doing the 10 and 11 no more.
Okay. We're going to do the other one. Is that what you're asking? Yeah, we're going to do that one too. But this gives you minus 11 and a half seconds. Now you're asking about this one over here? Yeah, what will you do with that one? Add 5 to both sides, and that gives you t is equal to 5 seconds. Remember, t is your time in seconds, remember? Now, if this was a regular math problem, forget the writing at the top. If this is what you were given, then those are your 2 solutions, right? But this is a real-life problem, okay? And it's asking for how much time, how many seconds later will the stone hit the bottom of the well. Okay? Now, does this make any sense? Minus 11 and a half seconds ago? Wait. No. Huh? Yeah, it's coming back up. Okay? So, no, that one makes no sense. Time is always positive, looking ahead. So 5 seconds is your one, and in this case, only solution. Mathematically, this is a solution. Realistically, practically, physically, not a solution. Okay? Because that was sometime in the past. There's your solution. 5 seconds after you threw it. And you're right. If it had been launched from the bottom of the well, it would have taken 11 and a half seconds to reach its maximum point, and then it would have come back down and hit the bottom of the well 5 seconds later. But we're not launching anything. You threw it from the top. So therefore, only the positive time works. Does that make sense? Now, back at this stage, okay, okay, with the original problem here, at that point, I think I would have, just to keep from hauling around all those big numbers, I'd have said, hey, every factor there on both sides is divisible by 8. Divide by 8 up there. And then your whole problem would have been a lot easier. Okay? But you didn't have to. The way you did it was fine. Or you could have done it right here, and then at this point, divided by 8, and then you're rid of the 8, because 0 divided by 8 is still 0, and you don't have it over here. So you could have gotten rid of the 8 here, or where we did there. Okay? When we said, oh, 8 can't be 0, so therefore it's thrown out. Down here we got time can't be negative, so it's thrown out. And we're left with one answer. T is equal to 5 seconds. Okay. Let's see how they did it. Let me erase it. Any questions on this before I erase it? Okay. All right. To find the time for the stone to drop, I don't like that term there, drop, because it was thrown to the bottom of the well. To reach the bottom of the well, replace the variables t and v with the given values, which we did, and then solve for t. Now look at what they did. Oh, no, they just wrote it. V is equal to v t plus 16t squared, exactly what they were given. Plugging in 440 is equal to 8t plus 16t squared. And they did exactly what you did, subtract the 440 from both sides. I would have gone on and divided by 8 there, but they didn't. It's fine. Okay, factored out the 8 just like you did. And then divided out the 8. See, they did it at that point. They said, well, let's just divide both sides by 8. Well, 8 divided by 8 is 1, and 0 divided by 8 is 0. So now you're left with that. Now you don't have to worry about the 8 anymore. Okay, now they factored that one to be 2t plus 11 times t minus 5, just like you did. And then they said each of them equal to 0, just like you did. And that gave you 2t is equal to negative 11, t is equal to 5. And when you divide that one by 2, negative 11 halves, because time cannot be a negative number, negative 11 halves is not a solution. Not realistic, not physically possible to have a negative time. So the t equal 5 is your one and only one solution. Make sense? All right, good deal. Any questions on it? Any whatsoever? Okay. Got it? Okay. Everybody? And that there is an application problem there, check your understanding problem there on page 27 of module 11. And if you want to see that one done too, we can, or that can be a good one to do as soon as you get out of class, whenever you have free time. Anyone need it? Okay, and then they have 3 objective 11.5 practice problems. I would highly recommend you do those 3, because if they're putting this much emphasis, I bet you their test bank will put that much emphasis as well, and that's where I draw my test questions from. So I'd recommend you do the work on those objectives. Okay, what do you call them? Practice problems. Okay, and the other, and to check your understandings. So here's all your solutions for Module 11. You check your understandings, begin on page S1 and goes through S wherever. Wow, a lot of them here. And S6, and then beginning on S6, you have your solutions to the objective practice problems beginning on S6 and going through S12. Okay. Any questions on Module 11? So the test for it will be Wednesday. Okay? Everybody okay with that? All right. Can everybody get the quizzes in by Wednesday? If you can get it to me anytime today, I'll be here till 6 o'clock this evening. Get it to me anytime tomorrow. I'm here from 8 o'clock until 6 again. So now I'm in class a lot of that time. So if I'm in class, you can either bring it in quietly and give it to me in class or slide it under my door. My office door is 265. Okay. Across from the orientation classroom, if you know where that is. Okay. Now, if no questions, let me go on and let's get started in Chapter 12. Now, if you think that, all right, we've finished with factoring now, we've done that chapter, guess again. All Module 11 pretty much was getting tools in your tool belt so you can actually do some more complicated type problems, some of which are these things called rational expressions. Okay? Now, this is Module 11. What does the term rational mean to you? And it's not gender specific, by the way. Okay, you can go there. Okay? What does rational mean to you? Say again? Okay. Let me cover 3 letters. What does that say? Ratio. What is a ratio? Basically, the definition, a comparison of 2 numbers in a division sense. 7 to 3. The ratio, 7/3, 7 to 3. 7 divided by 3. That's what a ratio is. So a rational expression will be an expression that you have a ratio of 2 entities. Okay? What will those 2 entities be? Well, right now, they're going to be polynomials, which we just finished doing. Okay? So here we're going to have rational expressions, ratios of polynomials. Okay? Section 12.1 will be the multiplication and division of rational expressions, which, hey, wait a minute. Don't we usually start with the easy stuff, adding and subtracting, before we do multiplication and division? Well, guess what? In rational expressions, multiplication and division is the easy stuff. Addition and subtraction takes a little more effort. And I think you'll recall this if you don't know it already. Okay? So objective 12.1A, first thing we're going to do is simplify rational expressions. Okay? We're going to start with that, then we'll get around to multiplying and dividing. Okay? So let's start with simplifying rational expressions. All right. What other things are ratios? One thing divided by another. One thing written over another. Fractions. A fraction is a ratio. So a fraction in which the numerator and denominator are polynomials, that's what we mean by a rational expression. Ratio of 2 polynomials, rational expression. Here's examples. Okay? A fraction would be 5/7 would be a ratio. Okay? A rational expression. It's just really simple. 5 over z, monomial over monomial, that's a rational expression. X squared plus 1 over 2x minus 1, rational expression. Polynomial divided by polynomial, polynomial divided by polynomial. Yeah, all those are rational expressions. And frankly, all those cannot be simplified. They're as simple as they can be right now. Okay? Why couldn't you simplify this in? Okay? Sum of 2 perfect squares is never factorable. Okay? And this can't be separated as simplified because it's already in its simplest form. There's no common factors. Here, if that was a perfect square, you could have, but it's not a perfect square, so you can't simplify that, and this can't be factored any further either. So yeah, those are already in simplest form. Now, care must be exercised when working with rational expressions to ensure that the resulting denominator cannot be what? 0. You can never divide by 0, ever. So in this expression, as soon as you see it, it should pop in your head. If not writing on the paper, z cannot equal 0. Because it can't. Z can't be 0. How about this one? X cannot equal 1/2. Because if this was 1/2, 2 times 1/2 is 1. 1 minus 1 would be 0. Now this one, don't even go there. That's too complicated. But that should be one of the first things that pops in your head. The denominator can't be 0. The denominator can't be 0. Okay? Now what we're going to do, well, let's see what they say they're going to do. Okay? Okay? In this expression here, what can x not be? 2, because 2 times 2 is 4, and 4 minus 4 is 0. So yeah, you cannot have x equal 2. Any other number would be fine, but x can't be 2. Now, and by the way, these are in simplest form already. A fraction is in its simplest form when the numerator and the denominator have no common factors other than 1. 1's always a common factor, so except for 1. So the multiplication property of 1 is used to write a rational expression in simplest form. Now, I don't know if you thought of it in that term, but that's what it is. Sort of crazy, but we'll do it. Okay, so let's make sure they're starting in the right place. No, they're not. Let's back up. Well, actually, this is probably the best place to do it. All right. On Module 12, page 2, they have, before they get here, let me get my pen set up. Okay. They say simplify this. X squared minus 4 over x squared minus 2x minus 8. Okay? Now, I don't ever see them say it quite in this way, but when you're trying to simplify a rational expression, factor everything in sight, okay? Just factor everything, okay? And see what comes out. Is that numerator factorable? Yay or nay? What you think? I put down things in case they were. Do you think that numerator is factorable? That's x squared minus 4. Is that factorable? Help me. Somebody. It's what? I heard an x on x what? A little louder. Plus 2. Okay, I can't hear well. X plus 2 times x minus 2. Yes, it was factorable. How about that denominator? A little more complicated. Only way to factor the x squared. X times x. Okay, then we look where? Sign of the last term, that's a minus. So that means these two signs have to be opposites. So which way you want to write them? Plus, minus. It doesn't really matter. Okay? Now, because they're different signs, we're looking for two numbers that multiplied to be 8, but they're different. Because they're different signs, their difference is 2. Say again? 2 and 4. Okay, which one goes where? Plus 2 minus 4. Why? Because the minus sign wins, right? The middle term is negative. So put the bigger term being the minus 4. Now that works when the first variable is the coefficient of the x squared is 1. That works when you do that. If it wasn't, yeah, you got some more work to do. Now, what do you notice about these expressions now? Common factor of x plus 2. So you can divide it out. Now, that's what they're calling division by 1. Okay? Because x plus 2 over x plus 2 is 1. As long as x is not equal to, what can x not be equal to? Negative 2 or positive 4. X can't equal negative 2 or positive 4. Now, even though you're dividing out the x plus 2, it still can't be negative 2 because your original problem was this. If you plug the negative 2 over there, you get a 0 in the denominator. So don't do it, okay? As soon as you factor, then you know x can't be negative 2, x can't be positive 4. You can write that down if you want to. The book doesn't, so you don't have to. But that should be in the back of your mind. Can't equal those things. Okay, so what does that leave you with? X minus 2 over x minus 4. You can't simplify any further than that. Now, does anyone see any way you could, maybe? Second? Okay, I thought I heard take out a negative 2. Okay. If you were a gangster, you could take it out. Yeah. You know, take them out. Okay. But we're not gangsters. Okay. So, yeah, now, okay. If you could factor it out, that's what we could do. Because you can only divide out things that are multiplied. Are those multiplied? No. They're subtracted. So, no. Resist temptation. Don't try to take out the x's. Okay. That would be a gangster move. Or take out the 2's. That would be a gangster move. You can only divide out things that are multiplied. Here we could divide out the x plus 2 because it was multiplied here, this was multiplied there. So yes, you can divide out x plus 2. You can't divide out. And that's why most mathematicians stay away from the word canceling. Because canceling, it feels like you could just cancel things like crazy. Don't do it. Okay? You can only divide out things that are multiplied, not that are subtracted or added or anything else. Okay? Does that make sense? So if you're tempted to, resist temptation. Stay away from it. Okay. And that sure is what we got. And they also say in the side, and this book is actually saying it, x cannot equal negative 2 nor 4. Most of the time they're not going to say that, I think. But let's see. Yeah. If you look at the top of page 3 in module 12, in bold yellow highlight, for the remaining examples, we will omit the restrictions on the variables that prevent division by 0 and assume that the values of the variables are such that division by 0 is not possible. So they're not going to write that every time. They did on this one, they're not going to do it anymore. Okay. Now, here's another one to simplify. Let's just stay on the same page here. We haven't gotten to the one at the top yet. Here's one. 8x 6 y squared divided by 20 x y to the 5th. And frankly, folks, we were doing these in the last module, weren't we? Nothing new here, but that's a rational expression. We didn't call it rational expression before. We're simplifying a rational expression. Before we called it division, right? Okay, we were dividing polynomials. Here we're simplifying rational expression. It's the same thing. So what would you do there? Now, one technique, this is a little longer, but back when I was in the Navy, we used to say you had to make things sailor-proof. So not even a sailor could screw it up, okay? Huh? Private-proof, okay? You got the same concept, okay? So we said we had to make it sailor-proof. This is almost a sailor-proof way to do it. Again, factor everything inside. That's going to work anytime you're dealing with these. What's the smallest prime number that'll go into 8? Help me. 2. 2 times what? 4. Is 4 prime? No. What will it factor into? 2 times 2. Okay, there we factored our 8. Completely factored. Okay? Now this is really long and drawn out. X to the 6 would be x times x times x. times x times x times x. Like I said, you're trying to make it sailor-proof here, okay? Or, I'm sorry, student-proof. No, whatever, okay. 1, 2, 3, 4, 5, 6, okay? And y squared would be y times y. This is really long and drawn out, but I just want to show you what's happening here. How about 20? Smallest prime number will go into 20. 2 times what? Say again? 10. Is 10 a prime number? No, it's what? 2 times 5. 5 is prime, so you've done it, okay? Then you have just one x there. Then you have 5 y's. Y times y times y times y times y. Okay. Now, what can we divide out? Things, yeah, divide out your ones. There's a 1. There's a 1. That's all your ones of your numbers, right? There's a 1 there. Only 1 there. And let's do these 2 here, and you got all your y's that go to 1. What do you have left? 2 x to the 5th over 5 y cubed. Perfect. Okay. Now that's the long, drawn-out way to do it. Most of the time, I would say, what's the least greatest common factor between 8 and 20? 4. Okay, 4 will go into 8 how many times? 2. 4 will go into 20? 5 times. Same thing here. Greatest common factor between x to the 6 and x. X, right? X will go into x 1 time. X will go into x to the 6th. X to the 5th time. Okay. Subtract 1 from both exponents. Down here, greatest common factor between y squared and y to the 5th would be y squared. Both of those go out. When you take 2 away from that, you're left with 3. So you get 2x to the 5th. The problem with doing this, you sometimes will forget something here. 2x to the 5th over y, 5y cubed. Same answer. It's a little messier. That's longer but neater. This is a little messier. So if messiness is going to confuse you, don't go messy, okay? It confuses me sometimes, so I have to really watch myself. But doing that way almost makes it student-proof, right? So you should be able to do it, right? Or private-proof. Okay. All right. Good deal. Does that make sense? Now, you don't have to do it that way. The book didn't. They factored the numerical part, and they did the rules for the variable part. Okay? But they got the same answer, by the way. Okay. Okay. Let's see. I think they have yet another one here. This is a focus, but they didn't do the focus on the set, so I think I'll erase this. Is everybody okay for me to erase it? Still writing? Anybody? Okay, I'll leave you writing. Okay, you got it? Okay. All right. Everybody got it? Still see a few writing. It's okay? All right. One more focus here before we get to that focus, okay? Nope. Yeah. 4x cubed y to the 4th over 6x to the 4th y. Okay? Now, which way you want to do it? Second? The messy way? Okay, let's try it. He's calling me messy. Okay, all right. Greatest common factor between 4 and 6? 2. 2 will go into 4 how many times? Twice. 2 will go into 6? 3 times. Okay, we got that part done. Greatest common factor between x cubed and x to the 4th? X cubed. So those all go out, just leaving you a 1 there. So I'm not even going to write the 1. It's messy. And when you go x cubed into x 4th, what's left? Just an x. So there's your x. And then greatest common factor between y to the 4th and y? Y. Why not? Okay, and y will go into y 1 time. Y will go into y fourth how many times? 3 times. Y cubed times. Okay? So what are you left with in the numerator? 2y cubed over 3x. Very good. Any questions on that? Everybody see it? Oh, that's the shortcut method. If you see it better, just string it out. String it out, you know. Factor everything in sight. Carry them out there, then divide out your ones. Okay? It's a pretty straightforward method. Just takes a little bit longer. Okay? Any question? Well, it's all right. Okay. All right, that's followed by check your understanding 1. So please do those as soon as you can, that one as soon as you can after class to reinforce what we just did. Okay? This answer is on page S1. And now yet another here before we get to another focus. So let's do it here if we can. Here we have a 10 plus 3x minus x squared over x squared minus 4x minus 5. Now this is a little bit of a problematic problem, okay? What do you notice is an issue with it? Okay, how do you mean? Okay, and you're right. We call this is in increasing order, ascending order of your exponents. This is in descending order of your exponents. So yeah, they're sort of written backwards. Okay. Now, which way would you prefer them to be? Like the numerator or like the denominator? The denominator, that's what we call standard form. Okay. Now, here's the problem. If you write this in standard form, you're going to be leading off with a minus sign. And that's usually a little awkward too. So what we can do is factor out the minus 1 in the numerator. Okay? Or you could just factor out the whole expression. Okay? Well, let's just factor it out of the numerator. So first thing we're going to write that as a minus. You can put a 1 if you want to, but you don't have to. What will your new numerator be when you factor out the minus 1 and put it in descending order of powers? What will be your first term? X squared. Second term? Minus 3x. Good catch there. Remember, you're changing signs of everything inside. Next. Minus 10. Very good catch. Divided by x squared minus 4x minus 5. Okay? Now, I want to go off to the side and do a little scratching here. Let's take a ratio A over B. Okay? That's fine. Like that, right? But what if that were a minus A over B? What would be another way of expressing that that's exactly equivalent to it? Okay, that's the same as minus A over B. And there's yet another way to write it. It's the same as A over a minus B. When you have one minus sign in a rational expression, it can either go with the numerator, outside the whole fraction, or with the denominator. It doesn't matter. Those are all equivalent expressions. Okay? So what my temptation is to take, and I'm going to not yield to this one, I'm going to yield to this one, is move the minus sign out here. So we don't have it identified here, just have it in front of the whole fraction. Okay? Now, what's another way you could express this one? Anybody? Minus A over minus B. That would be the same, wouldn't it? Because minus divided by minus is positive. So this is actually the same as minus A over minus B. Anytime you have an even number of minus signs in a rational expression, it's the same as being positive. So why even mess with that? We don't ever go that way. If they were both negative, wipe out both negatives. Okay? Like if this were in reverse order and you put a minus here and there, and wipe out the minuses and plus, that would be wonderful. Okay. So what I'm going to do on this next step is put the minus out front. Now, what you reckon I'm going to suggest you do to that numerator? Try it anyway. Factor it. You got it. Okay. And guess what I'm going to suggest you do with the denominator? Factor it. Okay. Now, I'm going to show you my sort of cheating shortcut. Okay. But let's do. Which you want to start with? I really don't care much. Which you want to start with? Numerator, denominator. It really doesn't matter. Say again? Numerator. Okay. He likes to start at the top. Okay. Now, what would be the only possible factorization for that x squared? X times x. Very good. Then where do we look next? Sign of the last term, that's a negative, which means these two have to be opposite. So one's positive, one's negative. Very good. Now what we look for is two numbers, because this coefficient is 1 here, the x's are identical. We want two numbers that multiply to be 10, but because they're different signs, we want the difference to be 3. 2 and 5. Which one goes where? 5's with the what? Minus sign, and 2 with the positive sign. Okay? Good deal. Now, here's where I get really lazy. Okay? I really want one of those to go out. Right? So I'll look here and say, now, is x plus 2 likely to go into there? No. But x minus 5 could. So I'm going to hope x minus 5 might be a factor. This is just trial and error. I'm going to hope x minus 5 is a factor. What would that leave this first term to be? An x, and then it would be a plus 1. Now I'm going to check and see if that works. See, I'm really being lazy. I should have factored it. I should have taken the effort and factored it. But I was just being way too lazy and said, let's see if it'll work this way. Y'all aren't that lazy. Y'all are hard-working people, I can tell. Okay, never mind. Okay, x times x is x squared. X times minus 5 is minus 5x. Plus x would be negative 4x. And negative 5. All right. So now I showed you how to cheat, didn't I? Oh, I shouldn't do that. Instructors should not be doing that kind of stuff, should they? All right. But I did it. So what can we do now? Help me? Divide out the x minus 5, and what are you left with? Add, don't forget the minus x plus 2 over x plus 1. And can you simplify that any further? No. Okay, very good. A very definitive no there. All right. And they got negative x plus 2 over x plus 1. Good for them. All right. Coming up next time will be a focus at the bottom of the page, the one we never got to today. So we'll try that one next. And then once we do that one, we have another check your understanding. I mentioned you had to check your understanding. No, we didn't, did we? We did not. Okay. We'll pick up the rest of them. Well, actually, you have until next Tuesday to do those, right? Why? You got a test on Wednesday. I mean, next Monday to do them. You got a test on Wednesday. Okay. What's that? A third quiz? Just a second. Okay, you're really ahead. Okay. Yeah. Yeah. If it'll rest your mind,
Yes,
there are two that are not factored.
Okay. All right.
Is that rested?
Yes, sir.
Okay, good.
Thank you so much.
I didn't really intend to do that. I just hadn't checked the answers first.
Okay.
But that's fine.
All right. I sat like put it on trying to figure it
Good deal. Ooh. Okay, you don't even have a quiz. Okay. I gave it out before Wednesday. I've been out there a while. Those people turned it in. And so, you sure you didn't get one?
Can I see?
Yeah. Oh, wait. What's your last name? Huh? One more time.
H-O-O-D.
Good, yeah. Okay. I'm pretty sure you've already turned it in. Yes, look at that. Okay. All right. I'll leave these here.